Okay, so today's topic for discussion is related to fluid coupling. So here the torque converter is in the form of fluid coupling used to transmit the power from the engine to the input shaft of the transmission. Torque converter uses the fluid, that is oil, to hydraulically connect the flywheel of the engine to the input shaft of the transmission. Unless the machine is equipped with a lockup clutch, there is no direct connection between the engine and the transmission, just the fluid drive mechanism. If we consider the example of two fans, working is like this. Operation of a fluid coupling can be compared to the action of two electric fans placed face to face. If we place the fans face to face and if we rotate one fan, then second fan automatically rotates. So this is the principle of operation here. So operation of a fluid coupling can be compared to the action of two electric fans placed face to face and close together. If one fan is running, the energy of the moving air will cause the other fan to turn. In a fluid coupling, the fluid acts like the air between the two fans. As with the fans, the output fluid power of the driving components acts as the input power for the driven component. If we see the example, if we see the video, if one fan rotates, then it rotates another fan also, like this. So initial left fan runs and it transmits the rotation towards the right side fan. So similar function is takes place here also. See here, left part is rotating, then fluid is rotating, and after that fluid runs the other, that is opposite part, and in this way the rotation is transmitted. So we'll continue. So in a fluid coupling, the fluid acts like the air between the two fans. As with the fan, the output fluid power of the driving component acts as the input power for the driven component. So here, impeller and turbine is provided. This figure illustrates the two halves of the fluid coupling. A number of straight radial blades extended from the inside to the outside edges. See here. Okay, these are the radial blades which is extended from the inside towards the outside edge. The blades in the part of the right side are a part of the housing. This is the part of housing. This part is called the impeller or pump. This is also called as impeller and also called as pump. The blades in the part on the left side are part of the turbine. The impeller changes mechanical power from the engine to the fluid power, and the turbine changes fluid power back to the mechanical power to drive the transmission. The impeller and turbines are mounted very close together for efficiency. If we see the turbine cross section, this is the cross section of the turbine. The turbine and impeller have a rounded profile. When the turbine on the left is cut along the axis, its cross section will look like the illustration on the right. Fluid coupling oil flow. This schematic representation of the fluid coupling, the pump impeller shaft that is red in color connects to the engine flywheel. The turbine output shaft, that is blue color, connects to the driven unit. The impeller and this is the impeller and turbine both turn the housing. They are not directly connected together in any way. The housing is filled with oil. When the engine is started, the impeller starts turning. As the impeller turns, it throws oil from the center towards the outside edge. The shape of the impeller and the centrifugal force move the oil outwards and across into the turbine. The oil strikes the turbine blades. The energy of the moving oil is absorbed by the turbine and starts the turbine turning. As the oil strikes the turbine, the oil slows down and flow inwards towards the center to re-enter the impeller. When the oil leaves the turbine, it is flowing in a direction opposite to the oil flow in the impeller and tends to oppose the impeller. The heavier arrows inside the impeller represents oil increasing speed and energy as it moves through the impeller. The smaller arrows inside, okay, these are the big size arrows and these are smaller arrows. The smaller arrows inside the impeller represent oil slowing down and losing its energy to the turbine. Then rotary oil flow, if we see this figure illustrate the two basic kinds of oil flow in a fluid coupling, that is rotary flow, large arrows, these are the rotary flows, and vortex flow, that is small arrows. Rotary flow occurs when the oil is traveling with the impeller and the turbine in the direction of rotation. This happens when the impeller and turbine are traveling at nearly the same speed. For example, when the machine is coasting or when it is being roded, the oil is thrown outwards by centrifugal force in both the impeller and turbine, small, that is small arrows. The oil simply follows the impeller and turbine around and around. Large arrows, if we observe these large arrows. Vortex oil flow. Vortex oil flow occurs when the oil is traveling outwards through the impeller across the turbine and inwards through the turbine back to the impeller. The impeller is turning with the engine. The turbine is stalled or held stationary by load. The oil traveling across and striking the turbine blades limits oil movement in the direction of rotation with the impeller. The oil flows path looks like a spiral, like this. Oil flow path, which is spiral in shape. Then with vortex flow, there is maximum slip between the impeller and the turbine. The output torque is greatest when the turbine is stalled. Under a normal operating conditions, the oil flow in a fluid coupling will combine both rotary and vortex flow. The imaginary oil flow path will be like a coil of wire which loosens or becomes tighter depending upon the amount of degree of slip between the impeller and the turbine. This is the torque converter. A torque converter is a fluid coupling with the addition of a stator. Like the fluid coupling, the torque converter couples the engine to the transmission and transmits the power required to move the machine. Unlike the fluid coupling, the torque converter can also multiply torque from the engine, which increases the torque to the transmission. The torque converter uses a stator, which directs fluid back into the impeller in the direction of rotation. The force of oil from the stator increases the amount of torque transferred from the impeller to the turbine, creating the torque, that is multiplication. Torque converter components. If we see first, this is the rotating housing. Rotating housing and impeller turn with the engine. Then the turbine, the second part, turns the output shaft. The stator, third part, is fixed and held stationary by the torque converter housing. The oil flows upward from the rotating impeller around the inside of the housing and downward past the turbine. From the turbine, oil is redirected back to the impeller by the stator. The rotating housing is connected to the flywheel and surrounds the entire torque converter. An inlet relief valve and an outlet relief valve controls the amount of oil pressure that is held in the torque converter. Impeller forces oil against the turbine. The impeller, that is red in color, is the driving member of the torque converter. It is splined on the flywheel and turns at engine RPM. The impeller contains blades which force oil against the blades of the turbine. As it spins, the impeller slings the oil outwards towards the inside of the rotating housing. Oil is moving in the direction of rotation when it comes off the impeller blades. Impeller forces oil against the turbine. The turbine, that is blue in color, is the driven member of the torque converter with the vanes that receives the oil from the impeller. The impact of the oil from the impeller on the turbine vanes causes the turbine to rotate. The turbine causes the output shaft, which is splined to the turbine, to turn. The oil is moving in the opposite direction of the engine, that is flywheel rotation, when it comes off the turbine fins. The stator is the stationary reaction member with vanes that multiply force by redirecting the fluid flow from the turbine back to the impeller. If we see the purpose, the stator is to change the direction of the flow of oil between the turbine and the impeller. If we show the direction change, which increases the momentum of the fluid, thereby increasing the torque capacity of the converter. The stator is connected to the torque converter housing. Momentum of the oil is in the same direction as the impeller. Oil hits the backside of the impeller blades, causing the impeller to rotate. This is known as the reaction. If we see the oil flows continuously, the arrows in this figure shows the oil flow pushing outwards from the impeller and around the housing into the turbine. Oil drives the turbine and torque is transmitted to the output shaft. As it leaves the turbine blades, the oil strikes the stator, which redirects the oil towards the direction of impeller rotation. The oil flow is guided upward to re-enter the impeller. The oil flows continuously between the torque converter components. Oil flows continuously. If we see this diagram, we see oil is flowing. A torque divider provides the combined benefit of a torque converter and a planetary gear drive. The drive, the torque divider consists of a conventional torque converter with an integrated planetary gear set in front of it. This arrangement allows for a variable speed of engine torque between the converter and planetary gear set. The split can be as high as 70/30 depending on the machine load. Both converter and planetary gear set output are connected to the torque divider output shaft. Torque converter and planetary gear set. The torque divider is attached to the engine flywheel. During operation of the torque converter, the planetary gear set work together to provide the most efficient split of the engine torque. The torque converter provides the torque multiplication for heavy loads, while the planetary gear set provides nearly 30% direct drive during the light load situations. If we see this diagram torque divider, then if we see the cut section of this torque divider, then different components are there. This is the housing, this is engine flywheel, planet gears are there, then sun gear is there, output shaft, then this is the stator, then planet carrier, ring gear, turbine. If you see this side, this is the impeller, inlet passage, then outlet passage. Okay, all these components are related to divider. Torque divider components. Torque divider combines a fluid drive with a mechanical drive and adjusts to load conditions. Like the torque converter, the torque divider consists of 4 components contained in housing and that is filled with oil by a pump. The impeller, that is driving member, turbine, that is driven member, stator, reaction member, and output shaft operate the same as a torque converter. The torque divider also contains a planetary gear set. This is the torque divider operation. That is diagrammatic representation. Okay. So in this way, here we see the fluid coupling, and here we stop our lecture. Thank you.